Order of operations looked at from a slightly different, more effective perspective. Hey, please excuse my dear Aunt Sally. Poor Aunt Sally, was she have gas or something? I don't know. But anyways, the inverse operations. You've got addition and subtraction are inverses of each other. Multiplication and division, and powers and roots are inverses of each other, so they're pairs. Why is that? Well, if you were going to solve this equation right here, what would you do to get rid of the 7 that's attached by addition? You would use the inverse operation of subtraction and do that to both sides. Over here, you would add 9 to both sides. You would use addition to counteract subtraction because they're inverse operations. Likewise with multiplication and division. How do you get rid of this 3? How do you undo multiplication by 3? You divide by 3. On both sides. How do you get rid of division by 6? You multiply on both sides by 6. Inverses are powers and roots. How do you undo a square? You take now the principal square root of both sides, or a radical of both sides. And how do you undo taking the cube root of something? Well, you would raise it to the 3rd power. You do that to both sides. So powers and roots are inverse operations. So is multiplication and division, so is addition and subtraction. Keep that in mind, but let's get a better feel for why the order of operations are the way they are. Let's go back about 5,000 years to Egypt, and people are carving numbers into the sand, and it's just tedious and it takes a long time. So somebody says, whoa, I know, let's invent multiplication. So they did. And they said, you know what, instead of writing 3 plus 3 plus 3 5 times, let's stipulate this. Let's say that this means 5 times 3. It means we're going to add 5 3s together. So keep in mind, that's 4 operations going on. That's addition 4 times, all summed up in one more sophisticated operation of multiplication. All right, then multiplication, it's repeated addition of the same number. So multiplication is repeated addition of the same number. So check this out then. If we're going to evaluate this, we got 7 plus 5. Why don't we do the 7 plus 5 first? Well, if we did that, we'd end up with 12 times 3, which means we're taking 12 3s and adding them together. That's not what we have. We first have to account for the fact that there are 5 3s being added together. It's more sophisticated than just the addition. So we have to say, oh, 5 times 3 is 15. That's what you get when you add 5 3s together. Now we can add the 7 to that. So that's why multiplication has to happen before addition, because multiplication is repeated addition. Likewise, if we have multiplication, years ago somebody said, I'm tired of doing multiplication over and over and over again. I'm still carving in the sand. So what we want to do is invent powers that have a base like 3 and an exponent like 5, telling us how many of these bases are being multiplied together. So this is equivalent to that. This really has 4 operations. 4 multiplication operations all in one. It's more sophisticated. 3 to the 5th power. All right, so power is a repeated multiplication of the same number, like 3 to the 5th. They have a base and they have an exponent. 4 is the base, 3 is the exponent. The exponent tells you how many of the bases you're multiplying together. So this would be equivalent to 4 times 4 times 4. So powers. Okay, so now, if we're doing this guy, 6 times 2 to the 4th, how come we have to take care of powers, exponents, before multiplication? Well, because this bugger right here is really 3 multiplications in one shot. It's 2 times 2 times 2 times 2. That's 3 multiplications of 4 2s. 4 2s are being multiplied together. There's 3 operations though going on there. So that's got to happen first before you can turn around and multiply it by the 6. So we have to take care of powers before we do multiplication. Otherwise, it wouldn't make sense to do 6 times 2 and get 12 to the 4th power. That would be incorrect, because that would be saying you're multiplying 4 12s together. You're not. You're only multiplying 4 2s together. The higher order operations are the more sophisticated operations. So keep that in mind. I would argue that instead of calling it the order of operations, we should call it the order of sophistication of the operations, because powers are repeated multiplication. Multiplication's a step below. Hey, it's repeated addition, and at the lowest level is addition. It's like, that's all we got, addition. We don't have multiplication, which is repeated addition, or powers, which are repeated multiplication. So more sophistication as you go to the higher order of operations. So in addition, remember the inverse operations, so powers and roots are at the same level. They're inverses, they're just as sophisticated, so powers and roots get done first. Multiplication and division are inverse operations, but they're at the same level of sophistication. The lowest level of sophistication are the two inverse operations of addition and subtraction. But the most sophisticated operation are grouping symbols. Because look at this. If you got 5 plus 3 times 2, hey, normally you're going to do multiplication before you do addition. But multiplication is at the mercy of somebody coming in with a bracket and saying, we trumped the multiplication. The grouping symbol is more powerful than the multiplication. We have to do what's in parentheses or grouping symbols first before we can continue following the order of operations. That is why the most sophisticated operation is a grouping symbol. Take a look at this guy right here. Right now, what would you do first? Addition or the power? Well, the answer is you should take the power first, unless somebody walks in with some sort of a grouping symbol, like let's say a brace, and now, the grouping symbol forced you to do addition before you took the power. So the most sophisticated operations are the grouping symbols. So if we keep this, put it all together, we can do please excuse my dear Aunt Sally, but honestly, some kids in memorizing this think that you do multiplication before division. It's a tie. They're at the same level. They're inverses of each other. They're just as sophisticated. So it would be better if we said do grouping symbols first, then powers, then multiplication or division, and then addition and subtraction. But I think the best thing to do, instead of having mnemonic devices and memorizing stuff, is just to say, hey, what's the order of sophistication of the operations? Well, the lowest order is just addition and subtraction. You just have one operation to do. The next level is multiplication and division, and then powers and roots, and then grouping symbols after that. Why? Why is this the order of operations? Well, again, right down here, if you've got like 7 plus 5, that's it. There's only one operation going on, it's addition, it's a no-brainer. But now, if we did 7 plus 5 times 2, this would mean that you have 5 2's being added together. There's actually 4 operations simplified by multiplication. You're doing 2 plus 2 plus 2 plus 2 plus 2. There's 4 additions going on when you multiply 5 2's together. So multiplication is much more sophisticated than just one time adding something. Multiplication's got to be done first. Likewise, powers and roots. Well, what if you have 7 plus 5 times 2 to the third power? Well, you've got to do the 2 to the third power first. It's not okay to just do this one multiplication of 5 times 2. What happens right here is you're actually taking 3 2's and multiplying them together. That's 2 multiplication operations. 2 times 2 times 2. So there's 3 2's being multiplied. There's 2 multiplication operations that are being simplified by a power. So you got to do the powers before you can do the multiplication. So it's all about looking for the more sophisticated operation, and that's why these are the orders of the operations. And you saw before that grouping symbols trump everything. So you could make sure that you even did addition here first by putting brackets around here or whatever. So, the order of operations. First thing you should try to do is grouping symbols. Second thing is powers and roots. The third level is multiplication, division, and finally it's addition and subtraction. And so if you were to do a problem, if you were to do a longer problem like 6 plus 2 times 5 plus 3 minus 2 to the second power. Well, what would you do first? You go through and do all the grouping symbols. So the first thing you do is take care of this grouping symbol. 5 plus 3 is 8. Get in the habit, you guys, of rewriting everything. I know students don't like the tediousness of rewriting every problem vertically, but it keeps you out of trouble. You'll get the problem right. There's not that many long, ugly order of operations problems to do, so just take your time and do it the right way. Okay, we are done with grouping symbols. There's no more grouping symbols left. This parentheses is just to show multiplication. So we're done with that level. Now let's go to the next level. Are there any powers or roots? Bet your sweet bippy. Right there is. So that's the next thing we do. So we do 2 to the second power. That is 4. Now rewrite everything again. Quit the whining. We know that it's a lot of work to do some of these problems, but we'll get them right if we follow this approach. There are no more roots and no more powers left, so we're done with that level. Now we come down to this level, multiplication and division. There's only one multiplication going on. It's right here. It's 2 times 8, and that's 16. So we have 6 plus 16 minus 4. No more multiplication and division, so check that off. We're now down to the lowest level of addition and subtraction. There's addition here and subtraction here. That's a tie. They're both at the same level of sophistication. So now we work from left to right. So 6 plus 16 is 22. And then you got 22 minus 4, and that's 18. So think about order of operations as being order of sophistication, and it's just a checklist. Go through that level first, then this level, then this level, and this level. Work vertically, you guys. Don't want to see any equal signs in these problems. Just work vertically, take your time, do it in 5 or 6 steps. You're going to get the right answer. You don't want to lose easy points on a test because you wanted to do too much simplification in one step. All right, good luck.